Hi, I'm Lindsay Wazzola, and in this video, I'm going to be showing you some basic intro to the Shiny package in R. So before we get going, I just want to mention that this is going to be a live coding session, which means that I'm going to be coding here on my screen. And if you want to follow along with me, you can open a new RStudio window on your computer and type along with me as I go. The other thing that I want to mention is that I'm working on a Windows PC, which means that a few things like how I specify file paths are a little different than they would be on a Mac or Linux system. So, just think about that as you're going. If you find an odd error, that might be the source of it. The other thing that I want to mention before we get going is that we just need to make sure that we're all working off the right software base. So we have R and RStudio installed. We need both. And I'm down here in the console on RStudio. I haven't opened a script yet. I'm going to type library shiny, which is the package that we're going to need for today. And then I'm just going to hit enter. And that loads fine for me, which tells me that Shiny's installed and everything's good. If you get anything but this, you're going to want to make sure that you have all of Shiny and its dependencies installed. And sometimes the simplest way to do that is just to hit install.packages and then type Shiny, which I'm not going to run because I would have to shut down RStudio and reboot it. So assuming that we all have Shiny installed and everything's good, I'm going to go ahead and open just a regular R script by coming up here and clicking new R script. And in this new R script, I'm just quickly going to jot down some objectives for today. So our objectives for today are to code our first Shiny app, learn about the basic parts of an app, and build an understanding of something called Shiny reactivity, which is sort of the secret sauce to making Shiny great. And if following along with video tutorials isn't your cup of tea, we also have a tutorial that I made in R Markdown. So if you'd rather look at that instead of watching me build the app this way, you certainly can. Just go ahead over there. It's all the same content. Or if you would like to have this resource as a supplement later as you're working on building your own app, it's over there for you as well. So before we get going in Shiny, we're going to spend a little time here in RStudio just thinking about what kind of information we want to communicate when we're building an app. So we're going to start out with one of R's sample data sets called loblolly. Loblolly refers to a species of pine tree called loblolly pines that grow in the southeastern US. And I possibly could have chosen an easier to pronounce data set, but we're going to use this one. And if we just check out a little bit about what loblolly looks like, come down into our console here, we see that we have a data frame with information on tree height and tree age and a seed ID. So if we think about the sorts of things that we might want to know about a tree, an obvious thing that comes to mind is the kind of growth trajectory that a tree has over its lifetime. And we might visualize that by using the base plot function in R. And we can say plot on our x-axis equals loblolly age, and our y equals loblolly height. And we'll add some labels. It's unfortunately in feet, I believe. And whenever I'm running code and you don't see me click anything, I'm hitting Control Enter on my keyboard. So come down here into our plot window, and yep, there we go. We have a pretty linear looking trend between age on the x-axis and height on the y-axis. So that's all well and good, but what if we were working with a decision maker and our decision maker only wanted to know about trees up to the age of 10? Well, we could make a second data frame that I'm going to call loblolly small, and we could use our square brackets to say that loblolly small will contain only those rows from loblolly where age is less than or equal to 10 and all the columns. So if I hit that and I look at the first two rows of loblolly small, there we go. We have only individuals aged 10 or less, and we can of course make that into our plot. And there's our plot with our smaller pine data set. So that's all well and good. But what if we're working with a decision maker who's interested in different ages of pine trees, different age ranges? This is the point at which a Shiny app becomes really useful, because what we can do with Shiny apps is place all of our skill as programmers in the hands of decision makers by crafting tools that let them interactively change the inputs and outputs of a data process like this. So we're going to write our first app. I'm going to come up here to the top of my screen, and I'm going to navigate to the new file menu, and then where I clicked R script before, instead I'm going to click Shiny Web App. And here I'll be prompted to use an application, to specify an application name. And down here you can choose via your browser where to put the example, where to put the app. I'm putting mine in a directory called example apps. You can put yours wherever you like. And in the directory, or in the tutorial that I've linked to, I actually show you how to create a new directory from the R console if you would like to. So we have our folder where we're going to put our new Shiny app. I'm going to call it loblolly and click create. And there we go, we've got a new app. If I come down here to where my plot window is, and I instead click files and navigate to that example apps directory, I now see that I have a folder called loblolly that just contains one file called app.r. And this means that we've initiated our Shiny app as a single file app. You can also initiate it as a double file app, but we're going to stick to single file apps for now, just because they're simpler for getting going here. So now we have our Shiny app, which has initiated with a kind of sample app. And I'm just going to adjust my screen a little bit and squish this over so that we can look at the code. And whenever we want to run our app in the RStudio window, we're going to come up here and click this button that says Run App with the green triangle. And when we click the sample app that initiates in our new file, we see this app that creates a histogram of eruption frequency from the Old Faithful Geyser in Yellowstone National Park. And we see that we can adjust the slider, and it adjusts the number of bins. So if you're following along at home, you can go ahead and play with that for a little while and just pause the video and come back when you're ready. But assuming that you're ready to keep going, we can take a quick look inside the anatomy of the Old Faithful app. So in the anatomy of our Shiny app, we have this library loading function up top, and this happens outside of the context of the main app. And I bring your attention to that because a lot of the time it's going to be really efficient to do everything that has to happen once outside the main scope of the app. So this is things like loading libraries or defining functions if you want to do something like that here quickly, although I would suggest doing it in a separate script. But so that's where we're loading our library up top. And then we're going to come down into the main body of our app. I'm going to squish everything down so we can look at it. And we notice that we have two components. The first component is called UI, and the second component is called server. UI means user interface, and it's defined by this function called fluid page, which is a great simple way to define a page, because fluid page basically just uses rows and columns to visually describe a web page. And if we come down here into our console, we can type the question mark, and then we can type fluid page, like we would with any other R function to access the help file. And over here we get our full description of fluid page. And I would really encourage you, anytime you're trying new functions in Shiny, to work this into your workflow, because the Shiny documentation is really fantastic. And even though I've been working with Shiny for a while, I still find myself referring back to the documentation and doing this a lot. So it's just a good habit to establish. So we're defining our page called fluid. We're defining our page using the fluid page function. And the user interface holds everything that the user is going to interact with. So if you want to think about the user interface, you can think about it as sort of the web page that the user is going to see and touch and manipulate. So our user interface defines a title called Old Faithful Geyser Data, and then it's going to use something called a sidebar layout, which, if you recall, was this is our sidebar here. So this is the layout that places one bar off to one side of the page, and then a main panel over here on the other side of the page. And this is a really nice layout because it sort of encourages users to move from left to right as folks in Western cultures tend to read, and creates a natural space to put kind of those interactive widgets like our slider and instructions to the user on how to use the app. So here's our sidebar layout. And then within sidebar layout, we're going to nest this function called sidebar panel, which is how we define that panel with the number of bins, and then main panel, which contains that plot output. So if we look at nested inside the sidebar panel here, we have our slider input, which is the way that we were controlling the number of bins in the histogram. And you'll notice that slider input sort of has two names. So it has this first name here, bins, and then it has a second name, number of bins. And this sort of double name system is really important to understanding a lot of Shiny applications. So we're going to come down to the console again, and we're going to hit the question mark and type slider input. And if we look at the arguments to slider input, what we see is that that first line there is an input ID, and the second line is a label. So the first line, bins, is the name that Shiny takes and then passes to the server where all the calculations are done. So this is sort of like R's name for the object. And then the second line, label, which is number of bins, is the text that's shown to the user. So this is the machine readable name, and this is the human readable name. Coming down, continuing on our slider, we have some other parameters here. One of them is a minimum. So this is the minimum range of the slider. And then of course we have a maximum, which is 50. And there's a value, which is where the point on that slider range where it starts. So I'm gonna come back to main panel in a moment. I just quickly wanna hop down here. So what's happening down here in server is server takes input and then sends output. So you notice that we define server as a function using the curly brackets here. And that's because server is sort of the actual computer side, if you want to think about it. So server is where Shiny's doing all the operations that depend on the user output, and then it's creating those reactive visuals and those reactive values and sending them back to user interface. And this reactivity, the feedback between UI and server, is sort of the magic of Shiny. So in server here, we're going to create a value called dist plot. So notice that we are creating a container called output, which we see also up here. So this is how we know to send things back up to UI. So inside output, we're going to create an object called diskplot using the render plot function. And notice that render plot has these sort of special parentheses and then curly brackets. And that's how Shiny knows that we have a reactive value. So everything that's happening inside that render plot function is going to happen in a reactive context, which means that it's depending on that user input and it's going to update when the user updates the way that they're interacting with the app. And this sort of reactive context dynamic is really, really important to Shiny, because by isolating things that have to reload every time from things that don't have to reload every time, we can really reduce the memory and the processing time needed to make Shiny apps work. So what this render plot code block is doing is it's making an object called X that it's defining using the faithful data set. And faithful is, if we come down to the console, faithful is another sample data set like Woblolly. So you see faithful has 2 columns, eruptions and waiting. And if we wanted to highlight and run that little bit, we see that what we're getting is just a vector of numbers. So the amount of waiting time. So that's all well and good. And we come down to the line below that where we are looking at the object called bins. And what bins is it's an object that's a sequence from the minimum of x to the maximum of x. And so down on this line, we're defining an object called bins. And bins is defined by a sequence from the minimum of x, so the minimum of the waiting time, to the maximum of x, the maximum of the waiting time. And then it's specifying the length of the vector using this length.out argument here. So length.out is the number of items in the sequence. And we're defining it using the user input called bins. So if you remember up here, we defined our slider input using an argument called bins. And what that does is it's telling Shiny to look in the container called input for an item called bins that we can then use in server. So if we come back down to server, there we see it, input bins +1. So R is then taking that user input in this reactive context and then using it to draw the histogram. So here we see this histogram, which is drawn based on the number of bins, which is determined from user input based on the data provided. And then we see that whole object being saved to this object, output diskplot, which is again an object called diskplot in our container called output, which is sent from server back up to UI. And here's the really important part. We need to make sure up in UI that we're creating a place for that output to be displayed. So we're going to do that in our main panel by using the plot output function and then putting in quotes the name diskplot. And what that does is it tells R to look for an object called diskplot inside our output container and display it in our main plot. The last thing we need to round out this app is the Shiny app function down here, which tells R to run the app looking for a UI called UI and a server called server. So in this video, to wrap up, we discussed the reasons why we might want a Shiny app, and we used the example app that comes with Shiny to dive a little bit into the structure of the app and Shiny reactivity, which is sort of the wonderful magic of Shiny. In our next lesson, we're going to pick up here and we're going to build our own app that lets a user create custom plots from the Woblolly function. Thanks for listening, and I'll see you next time.